Here's integrated 3. This is problem 12-62. It's a system of equations for us to solve. We've got 3 equations and 3 unknowns. So we're going to use substitution or elimination. When I first looked at it, I wanted to use substitution because it was set up nicely with the x and the y. But then I noticed that would soon cause problems for me. So what I'm going to do is elimination. I'm going to rewrite the first equation. I just left it alone. The second equation, I just lined it up. I made it so the x's and y's and the constant line up. So see, I just moved the y and the x. Okay, so this is the second equation. And then I did the same thing with the third equation. And so now they're all lined up, and I can just add them the same way I do every other system of 3 equations and 3 unknowns. I'm going to add the first 2 equations, and that's going to eliminate my y. So x plus x is 2x, and the y's canceled out. Z plus 0 just leaves z, and 40 plus 5 is 45. So this gives me an equation with 2 unknowns, and then I'll take the second equation and the third equation, and I want to do elimination on them, so I must multiply the bottom equation by -2 to cause the x's to eliminate. So see, if I distribute this -2, that's what I have written here. Okay, and then so now I have it all set up where I can add. I've got 2 equations with 2 unknowns, and they're all lined up, so I'm just going to add the equations together. The x's cancel out, the z's end up being 5z equals 45, so z must be 9. And I can plug z in somewhere. Let's plug it in to the bottom equation. X equals 2 times 9, that's 18, x is 18. And then I'll plug, I want to find y, so I'll plug in 18 for x up here, and I've got y is 13, and then I can rewrite it as an ordered triple